Hi everyone, welcome back to the channel. So today we will be discussing another problem from our SD sheet. I'll just check if we are live yet. Mm, Why am I not seeing myself live? Okay, I think we are. Okay, so let me show you the problem statement from DP section. We will be solving this longest common substring. Okay, so what is given to you? You are given two strings. Your task is to find the length of the longest common substring. Very frequently asked question. Now this has become so common that good variations of this pattern is being asked. Let me show you what we have to do. Fine. So for example, you are given two strings here. What are those? I'll just ABC. Let's say I have S1 as A, B, C, D, G, H. Okay. Other one is S2 is A, C, D, G, H, R. First of all, what is a substring? Very basic thing. A substring is the consecutive pattern of string from the given string. It is a part of the given string, but it has to be consecutive. For example, if I have to write, I am writing a string ABC. What are the possible substrings of ABC? So A is a substring of length 1, AB is one possible substring, ABC itself is a whole string, is also a substring. Okay, uh, no character. You remember in mathematics we used to have when we used to write the subsets, we used to have a 5 set. Similarly, I can have an empty string, but I will not include it as one of those. I'm just telling you an empty string can also be considered. Next up, what we have is I can have B, single character B, then I can have BC, and I can have just C also. So these are some of my possible, these are all the substrings I can find from this given string. Is AC a substring? No. Why? Because the characters are not consecutive. I hope you understood the meaning of substring now. Now what you have to do is that in this question you have to return the length of maximum biggest substring that you can find common in both S1 and S2. If I just check what would be your random approach, the brute force approach or whatsoever, you will go ahead and check one by one each character. I found AA equal. I found AA matching. I go to the next character. I see B and C are not matching. So there is no point of going ahead by taking A into consideration as the first character of my substring. I can say so far A is the only largest substring that I have found. Now if I start from B, okay, I'll check with C, they are not matching. Should I go ahead and compare B with D? Let's see if I find. So here I found C, here I found C. Can I say that CD is one of the characters which, first of all, they are matching, right? Now C itself is of length 1. Right now I have A also of length 1, C also of length 1. One thing that you should understand here, when I matched B with C, I saw both were not matching. So I just moved one step ahead in S1 and I stayed one step here in S2. So what I want to tell you that you have to explore all the possibilities, no matter whatever indexes they are. What we need is that one part of a string, one substring matches the other substring in S2. That's the whole point. No matter what indexes they are, they don't have to match the indexes. Okay, so just showing you randomly. C is matching C. Okay, when both the characters are matching, you move your iterator in both the strings to the next index. Got it? Why? Because both the characters are matching, so you compare the next character. Now here again we have both the characters matching, so I'll move my iterator to the next index again. Okay, in both the strings it will move to the next index. I am seeing that G and G are again matching, so I'm just writing what I've found common so far, C, D and G. When I found any character common in both the strings, I'll move my iterator to the next index simultaneously. Then I find H and H again matching. Okay, I move my iterator to the next index. For example, if I'm just extending it, for example, if it was U V something like this, okay, and let's say here it is W. Now if you see, so far I found CDGH as my common string, and the length is also so far the maximum. Now my iterator, here it is pointing to U, here it is pointing to R. When I see U and R are not matching, okay, am I going to move my iterator to the next index in both the strings? No. If U is not matching with R, I will check maybe the next index in S2 might match with U, although it's not matching here, and there could be other possibility also. For example, if here it was R, right? So I saw U and R were not matching. I chose to move this iterator. What if these were not matching? So let's say I move this iterator, the iterator in string 1 to the next index, and then I try to match. They are a match. So for now I can say I have found a substring of length 1, for example, just forget about it. Then this could also be one of the possible substrings, right? So what I want to tell you here is that whenever there is a mismatch, right, going in the linear direction, just trying to check by just moving the iterators to the next index in both the strings is not going to help us, right? You have to explore the possibilities. What are those possibilities? Keeping the index same in S1 and moving the index to next index in S2, or keeping the index in S2 at the same position and moving the index to the next one in S1, right? So these are the different possibilities. Now to simplify this, that is where we are going to make use of dynamic programming. So what dynamic programming lies on? That we are making use of the answers that we have gotten from the smaller problems, and to reduce the time complexity of, let me show you one second, of processing the any particular case again and again that happens in recursion. That's where DP comes to a rescue, by minimizing those number of calls, by just calculating the answer for one particular smaller subproblem and using that to calculate the answer for the bigger subproblems. Now theoretically I have said, now let's understand what do we mean actually. So let me take these two strings like this. I'm just writing in small for the ease of writing, don't get confused. A B C D G H, A B C D G H. Okay, let me take a okay. Next up I have is another one is also A just wait for some time. A C D G H and R. This is what I have in the other one. Okay. Just a minute more while I draw this entire table. Okay, I'm done. Yeah. Okay, so as you can see, I have drawn a grid here where on one side I have considered rows corresponding to the characters of S2. For example, you can take it anyway, S1 or S2 can be on any side, doesn't matter. This is ACDGHR, this is S2. Okay, S2 and this is S1. So the point here is that before we move to this grid, let me simplify this. For example, if I have strings like ABC and GBC, for example, okay, what would you do in this case? See, I'll go and check the first two characters, right? First, I just compare A with G. Are they a match? No, they are not a match. Then I move to the, since they are not a match, I will compare ABC with BC. One is this case. Other case is that since A and G were not matching, I dropped G from here and compared it with the entire string of S1. And in the other case, what I'll do, I'll compare BC with GBC, maybe if that's a match. Okay, now repeat the same process for ABC and BC. You check A and B, again are not a match. So what are the two possibilities? That you drop this character from first string and compare it with the other and as it is. In the other case, you take it as it is and drop the first character from the other one and compare it with B. You compare it with C, right? So same thing you repeat for the rest of the cases. Whenever there's a match, I'll tell you. For example, I'll calculate for this case. So this is kind of a recursion tree that I'm drawing in, not exactly, but you can have an intuition of how recursive calls might look like when I'm trying to compare the characters to find the common substring. This was one case, right? This was the other case. From this one case, I found two more cases. Now how? Based on the comparisons of the first characters that I have now, consider this as the remaining string. First character is not a match, right? So what are the possibilities you have? That you compare C with the entire string GB, and the other possibilities that you compare BC with B. Okay, now you come back to this case. For example, you compare first two characters. Whenever there is a match, you drop both the characters from the string and compare for the remaining part. Okay, and is there any other case possible from this string? No. Whenever there is a match, you just drop both the characters and check for the remaining part of the string, right? Now when I compare A with C, it's not a match, right? So what could be the other case? That you are comparing BC with C, and the other case could be that you are comparing ABC with a null string. Basically nothing found from here. From here you will maximum find a substring of length 1. From here also you found a substring of length 1, but you saw whenever there is a match, already a substring of length 1 has been found. When you compare these two, again a substring of 1 has been found. So to all together you will find a 2. How this 2 gets added, how this 1 plus 1 get add up to 2, that we will understand through this grid. You will understand how this thing will be happening. So I hope this idea is clear to you, that why we are not going to go through recursive method, because of the overlapping cases. You'll see somewhere, I'm not sure if right now, see here itself we found overlapping repetitive cases. See, BC and C I am comparing here also in my recursion tree, and I am comparing it here also in my recursion tree. So now let's understand it from grid method. How we are going to do this? The methodology will be same, the comparisons will be same, just we are going to do it here itself. So I have taken a grid of an extra row and an extra column, because we are going to evaluate our answer based on the previous answer. So I do not want, when I am evaluating from, for example, 0th index, I'll have to check for somewhere, let's say -1th index. There is nothing like -1 index, right? This is the reason we have already taken a grid of an extra length, and we will pre-place the values for these 0th row and 0th column. What it typically says, if you compare all the characters, this is an empty string, right? This represents an empty string. An empty string with an empty string, there is no matching character. Means there is no character which can be a substring, so answer will be 0. An empty string and any character, if you try to match, will you be able to find any substring from there? The length of substring will be 0. So I'm just writing 0 all here in the first 0th row. And if you try to do the same for the 0th column, here what it depicts, understand the depiction, okay? That is important, not how we are filling the grid. That is very easy, but on what basis we are filling, that's what you need to understand. Okay, what are we doing here in this case? I am comparing this character with an empty string. Will I ever find a common substring in this? No. So it will be 0. and you can replicate the same for every, because an empty string will not be a match with any character. So the values in the grid represent the maximum length of the substring that I can find common in both the strings. So basically they are processing their answers for that particular part of your string till that part. Okay, this much is clear. Next up, what, let me just check, if you guys have any doubts you can write in the chat, okay, because I'm just going with the flow, I might not see that. Okay, let's start from here. I see A is a match with A. Whenever there is a match, so I get at least one length of a substring from this matching part. Rest of the part I'll ask. So right now my string comparison is from S1 I have A, and from S2 also I have A. I see there is a match, so I ask, was there any match previously? So for to check if there was a match previously, I'll go to one length above in S2 and one length above, means to the left, in S1, that actually depicts the remaining string that I have already evaluated. By chance that's an empty string as of now, so that answer to me will be given by this value, the value in this box, which is just diagonally above it. Okay, so for A and A I will write 1 here because it's a match. Okay, now I'll compare A with this B. So this represents that I am comparing A from S2 with AB in S1. Okay, so I am comparing, is this character a match with this character in S1? If it is not, what can you do? Can you do something? No, you won't be able to do anything. You just move ahead. Okay, you just move ahead, because since it's not a match, you have nothing here. Again, when you are at C, you are comparing A with ABC. So from ABC you are trying to match A with C. Since it's not a match, so you do not find any substring here, so the length will be 0. So A is not a match with any of them. I am writing quickly 0 here. Coming at C, so basically I am trying to match C with A. Basically I have taken AC from S2 and A from S1. I am trying to see if C is a match with A. No, it's not a match, so it will be 0, right? Then you compare C with B, it's not a match, 0. Then you compare C with C. So basically you are comparing AC with ABC of S2, and the last characters you're trying to match with this C is trying to match itself with this. If it's a match, that means I will add 1 for myself, because at least one substring whose characters is C is common in both the strings. So at least one length of substring I have found. But do I have a consecutive part? Do I have a character which is consecutive to this C in my previous part of the string? So that answer to me will be given by the value that is diagonal to it, because the remaining string is A for AC and the remaining string for ABC is AB. So A and AB, A and AB will have its answer stored here, right diagonally above it. Since it says that there has been no substring which is common, if you try to add up C in it, there is no consecutive string character which I can find before C to add up into myself. So my answer will be just 1, that's C for C. Then there is no other match. C, D, G, H will not be a match, 0, 0, 0. Now I am at ACD. I am comparing ACD with A. D and A are not a match, 0. DB not match, DC not match. DD is a match. Since D and D is a match, you add 1 for yourself and ask diagonally above, do I have any other character which is right consecutive to me in the remaining part of the string that I had? So basically, when I compared ACD with ABCD, I compared the last characters, right, and the last characters DD were a match. So my task is to find in the remaining substring, do I have a consecutive character which can be added to myself to form the substring, and that answer I'll get from the diagonal above me. It says yes, I already have a length 1 of a substring which is common in both. D will say I will also add up 1. So 1 plus its own 1, it will be 2. Right, rest of them will be 0, 0. Same thing, GA is not a match, GB is not a match, it's not a match, it's not a match. GG, it's a match, and GG will add 1 to itself, 1 for itself, and it will ask diagonally above, do I have any other remaining, in my remaining string, do I have any other common substring? Yes, and that is of length 2. So when I add myself to it, I'll get 3, and GH will be 0. quickly I'll do. I hope you have understood so far. I'll just quickly do. It will be 0 0 0 0. H G again 0. H and H are a match. H and this H are a match. So I'll ask diagonally, do I have some substring in the remaining part of my string? So A B C D G and A C D G. It will say that it has already a substring of length 3 which is common to itself. So I'll add one of myself, so it will become 4. And R 0 0. There is no match for R in the other string. So finally what you see, you will see that as I am trying to fill the values in my grid, I am done. You will just keep a track of what is the maximum value you found so far in your grid. That will be your answer, right? So that is what we wanted. Our final answer was B, C, D. It was C, D, G, H, C, D, G, H. And we have seen how this grid of strings in which, not strings, the grid is of type integer only. Just you need to understand that how we are mapping one string with the other to generate the answer for ourselves, right? So that is pretty much about it. I'll just check if you guys have any doubts. Okay, so I hope you have understood this. If you have no doubts, I'll just move to the code now. Let me just show you. Code of DPs are very simple. The entire logic, the entire thing in DP is to understand what is happening. And also please don't memorize that, okay, we'll have a grid. You need to understand what kind of comparisons we are making and how we are just using a data structure to store our answers. Just understand that grid in this way, that it's just the data structure of which we are using to store the answer so that we can use it in future and generate the new answer. That's all. Everything in logic you'll understand when you understand the recursion tree of any particular question. Okay, so I'll just show you the code. So, and I hope you have also understood the fact why we have taken the grade of an extra row and extra column, and the rows and columns are equal to the number of the length of string 1 plus 1 and the length of string 2 plus 1. That is how it is. N and M are already given. Fine, let's start. Int DP, I'm naming it new int n plus 1 and m plus 1. Okay, then I'll generate the answer. Okay, for example, I'll be returning my final answer, which will be storing the maximum length of common substring that will be stored in answer. So I'm taking it 0. Now you iterate over the rows and columns of your DP array. So int I equal to, let's start it from 1. Initially, an array when defined, initially all the values are 0, and that's what we want. Actually, logically also we have seen that first 0th row and 0th column need not be changed, they'll remain 0. So I'll start from I equal to 1, I is less than equal to n, and I plus plus for int j equal to 1, j is less than or equal to m, and j plus plus, right? Fine. Next up we have, I'll just compare if s1 dot char at, so s1 I'll have its iterator as I, s1 dot char at I minus 1. Okay, since I've started from 1, but we on strings we are operating from 0th index of that string. Basically, if my I is at 1, but for s2 the index is 0, right? S dot char at 0 is where I'm finding this a, so that is why it should be s dot char at I minus 1 if this value, this character matches the s2 dot char at j minus 1, right? Then ARR of I, sorry, this dp of ij should be equal to, if they match, it should be equal to 1 plus what you found in the diagonal above it. So that you will find by dp of I minus 1 j minus 1. That will be the index where you will find the answer to the remaining part of the strings. Okay, and answer will be stored with math dot max of whatever you have in your answer already and whatever answer you just generated, dp of ij, that will be stored in your answer. Okay, and in the else case, what do you do? In the else case, you just mark that dp of ij with 0. If there is a mismatch, you are not going to do anything else but mark it 0. If there is a mismatch, there is no common substring for at least that part, you write directly 0 there. Fine. Come out of the loop, return answer. What's the error? Small s. Fine. So we are done with it. If you have any doubts, you can ask me. Otherwise, we are done with these questions, right? So let me check. So if there are no doubts, I'll just wrap this up. Okay. Okay, very simple, just two for loops. That's what we have used in that are iterating over the length of your string 1 and string 2. The time complexity is big of n cross n. That's pretty much, and also the space complexity is also big of n plus n cross n, n multiplied by m basically. To be very precise, n plus 1 multiplied by m plus 1, but it will come out to be big O of n into m, right? So yeah, that's all. Finally, we are done with this question. See you then in the next lecture. Bye bye. And